Good morning, children. Very good morning. So, in rational numbers, we have started discussing about commutative property. We have seen it under addition as well as under subtraction. Under addition, almost all the numbers are obeying commutative property, but under subtraction, all the number systems, right? Whole numbers, integers, and rational numbers, they disobey commutative property. Why? Because a minus b, if it is giving positive, b minus a, it is giving negative. Okay, so therefore now the next one is multiplication. What is the general rule? For all values of so and so numbers belonging to whole numbers or to integers or to rational numbers, they all should satisfy a into b is equal to b into a. So I am not going with the general form. Already that you are practicing it every day. So therefore let me go with, let me take a is equal to a whole number 0, b is equal to something like 3. So now here a into b here is equal to 0 into 3 is 0. b into a is also equal to 0 into 3 is 0. Right? So in either case you are getting like non-zero value. Suppose if I wanted to take a is equal to 2 and b is equal to something like 5. Let us do it. A into b is equal to 2 into 5 is 10 and b into a is equal to 5 into 2 is also equal to 10. This you have learnt in your lower classes only. Therefore, I am going for like the next one. Right. Now integers. Let a is equal to minus 5. B is equal to something like 4. Now let us do a into b. What is a into b? Minus 5 into 4, which is equal to minus 20. 5 4s are 20. Here is a negative number, therefore here also. Now the next one is b into a. What is b? 4 into a is minus 5. Why am I putting it in brackets? Because into and minus 5 should not come side by side. So you have to keep this number inside the brackets. So 4 5s are 20. So plus into minus, minus, so minus 20. So from these two we can say that a into b is equal to b into a. So therefore this obeys rational number, integers obey commutative property under multiplication. Even here we have seen that a into b is equal to b into a. This is true. This is true in case of whole numbers also. Now rational numbers. We shall take a is equal to 1 by 2, b is equal to minus 3 by 4. Minus 3 by 4. Now let me check with a into b. A into b, 1 by 2 into minus 3 by 4. I am putting minus 3 by 4 within brackets because into and minus should not come side by side. Right. So now it is multiplication. No need of taking LCM. You can multiply the numerator separately and denominator separately. So 1 into minus 3 is minus 3 by 2 into 4, 8. Right. Now let us do b into a. B, what is b? Minus 3 by 4 into, what is a? 1 by 2. So minus 3 into 1, minus 3, 4 into 2, 8. So a into b we got it to be minus 3 by 8 and b into a also we got it to be minus 3 by 8. So in both the cases we got the value to be the same. Hence we can conclude a into b is equal to b into a even in case of rational numbers. Even in case of rational numbers. So therefore for multiplication, commutative property is obeyed by whole numbers, integers as well as rational numbers. Is that clear? So now you might be familiar with all the rational numbers, right? By now, because we have seen our closure property we saw, and commutative property of addition and subtraction is done. Now multiplication is also done. Now the next part what we are going to move is to division. Right, some of the smart children might be already thinking about how to perform division. Okay, so because for in closure property, in case of division, the culprit 0 is there, where therefore you got something by 0 to be equal to infinity. So there was always a contradiction of the closure property. That means closure property is not obeyed by all these numbers. Right? And now we are going to under division. Now we shall see whether in case of all these things again commutative property of division holds good or not. Okay, so pause the video for a moment and please copy down this. Right, have you copied? Right, now in case of division, first we shall see with the non-zero values, because just now we discussed like with what 0 is going to do here. Right, we will discuss with the non-zero values first and then again with the 0 values. Right, so A is equal to something like 4, B is equal to 2. A divided by B is equal to, because in case of division, what is the commutative property? A divided by B must be equal to B divided by A. If it is equal, it is obeyed. If it is not equal, it is not obeyed. So A divided by B is 4 by 2, 2 times, so 2. B divided by A, 2 by 4, 2, now 4 is in the denominator, so you got the value to be 1 by 2. Very clear, these two are not equal, so therefore this is not obeying division, commutative property and a division. If you take 0, here 0, suppose if I take 0 here, so when you do A by B, something by 0 we are getting, that means infinity. Of course infinity is not a number, but just we represent it as infinity. And here B by A is 0 by something which is equal to 0. So both are not equal. Okay, so now let us take the same, like with A is equal to 4 and B is equal to 0. For this case, A by B is equal to, right, 4 by 0 is equal to infinity and B by A is equal to 0 by 4 is equal to 0. So therefore, it is not accepting or it is not obeying commutative property under division. Integers also. Right, we shall see in integers. A by B is equal to minus 5 by 4, whereas B by A is equal to minus 4 by 5. These two are not equal, so therefore it does not obey division. Now taking 0, like this only you will get the case. You do it by yourself with A is equal to something like 3 and B is equal to 0. You should only do this and then post me. Rational numbers. Now A is equal to 1 by 2, B is equal to, let us suppose 1 by 3, right, 1 by 3. Now A by B, my A is 1 by 2, by B, let me reciprocate it, by 1 by 3, right, take the reciprocal so that it will become multiplication, take the reciprocal. Reciprocal means denominator will convert into numerator and numerator will convert into denominator and division will become multiplication, right? Now this division has become multiplication and 3 by 1. This is 3 by 2. Now let us see B by A. What is B? 1 by 3. What is A? 1 by 2. So let us reciprocate it. 1 by 3. Division will become multiplication. Numerator and denominator will get exchanged. So what is this equal to? 2 by 3. This is 3 by 2, this is 2 by 3, both are not equal. So therefore, even rational numbers do not obey commutative property under division. If you take 0 again, first of all, in one particular case, it is not going to become a rational number because in P by Q method, Q is not equal to 0. Clear? So, in all the three cases, you can see that division, under division, commutative property is not obeyed. Commutative property under division is not obeyed by whole numbers, integers and rational numbers. Both are not equal. They are not equal. A into B is not equal. A divided by B is not equal to B divided by A. Is that clear? So, not equal to. We made just the equal to as not equal to in all the three cases. Okay, just children copy this and then now try to recollect everything whatever you have studied under rational numbers, so that I am going to post you the exercise and then you have to start solving the problems based on under which property they will come. Okay, and then afterwards we are left with associative property and distributive properties. So in the next class, let us discuss about associative and distributive properties. Definitely introduction is a little bit lengthy because you have come to higher classes. You should know all the things, all the concept just before you proceed to the exercise. You are not small children like after one concept, one or two problems are given. After one concept, one or two problems are given in an exercise. Now it is all together. You are supposed to take the whole concept and then use the concept in doing doing different kinds of problems given in only one exercise. So thus get ready to solve the exercise. Okay, see you children.